Hello YouTube, this is Tutoring Potential and today we are doing Florida's End of Course Geometry Practice Exam Part 2. This is going to start with number 7. Okay. Let's go ahead and zoom in. Okay. Alright, minimal sound effects from here on out. O is the centroid of the circle. It says what statement is always correct about triangle ABC. Okay, this is a strangely worded question, but the centroid is basically the point when I connect the three medians of the triangle. So they've shown one median, which is from vertex B to the midpoint of the opposite side being AC and the midpoint being E. So O is going to lie on EB. the other the other medians would be somewhere over here, somewhere over there. I'm not going to draw them to confuse the figure, but what it's asking is, okay, what is always correct? Well, because it's a centroid, because this is a median, E is the midpoint of AC. Let me just go ahead and write that out. E is the midpoint of AC. That means that AE, line segment AE, is going to be equal to line segment EC, which is choice D. It throws you off a little bit, which is always correct, but we don't need DC drawn at all for that. That's not related to solving the problem. Okay. Number 8. Point O is the circumcenter of the triangle ABC shown below. Which segment passes through point O for all lengths of sides of the triangle? Okay. The circumcenter is going to be where the three perpendicular bisectors of the triangle meet. So they've shown the perpendicular bisectors of the side AC, which is EO, and they've shown the perpendicular bisector of BC, which is OF. So the one they don't show is the perpendicular bisector of AB, which is going to be, it's going to somewhere here. And what's going to happen is the perpendicular bisector of side AB, the one that's not drawn, is also going to pass through O. So that's the perpendicular bisector for number 8 of side AB. Now, for whatever reason, this test wants you to know that the circumcenter of a triangle is where the three perpendicular bisectors meet. And then a few questions ago, they had a question about the centroid. Centroid and circumcenter, for whatever reason, they are holding students accountable for knowing that. Not usually the case, but again, I'm not writing the test. I have nothing to do with the creation of the test, so I'm just going to try and help students prepare for it. It's sort of an esoteric, just not often used in geometry, but is used on this test. Okay, see if we're in frame here. Not quite. Okay. Rebecca is designing a backpack and needs to determine the length of the adjustable strap that connects the shoulder strap to the backpack. The height of the backpack is 19.5 inches. This is the height. The shoulder strap is 12 inches. What is not a possible length for the connecting adjustable strap? Okay, let's forget that it's a backpack because this obviously doesn't look anything like a backpack. The connecting adjustable strap is just the third side of the triangle. So this is triangle inequality. So basically, the third side has to be less than the sum, but greater than the difference of the other two sides. And I guess we should note that it can't be equal to the sum, and it can't be equal to the difference. So the good thing about triangle inequality is it's going to be it's not bad to do the arithmetic. All right, so we have 12 and 19 and a half. Right, so it has to be, here are sort of boundaries. 31.5, it has to be less than that. Let's just call it x. And then the other is 19.5 minus 12, which is 7.5. Okay, what I was trying to get to is usually when they do this, it's going to be one of the two extremes. Okay, so all my numbers are in that range except A. So the answer to 9 should be A. 7, because 7 is less than 7.5. Just sort of visually real quick, what happens if, right, if I have a triangle, sort of a very obtuse triangle this way, okay, as these get flatter, what's going to happen, let's say this length is 5, this doesn't have to be that tiny, and this length is 5, right, I can't make a triangle that connects them because I'm on a straight line. Similarly, as we get close to a triangle with a very small acute angle, right, I can't, if this is, the triangle collapses in on itself, right? If the total length is 5, I can't have 2.5 and 2.5 because then there's no outward, right? It has to be, if these are 2.5 and 2.5, this has to be greater. Again, sorry, that's impossibly tiny, but when you do triangle inequality, the sort of takeaway from this is it's going to be one of the two extremes. So if they're listed least to greatest, it's almost always going to be either the first one or the last one. So that's a 50-50, right? And on a test, on a standardized test, those are pretty good odds. It's like true false. Okay. Let's zoom back in. Ruth Ann is buying a home, and the plot of land is triangular. She would like to have a long property line along the street. The given angle M, is opposite the roadside of the plot of land. So here's the road. So it looks like we're trying to maximize KL. And then it gives us 4 different plots for A, B, C, D. Those are just our answer choices. What it's saying is which of these angles at M will give the greatest property, give the greatest property line along the road. So what happens is, all right, the larger I make the angle at M, the larger the property line at M. So I'm just going to go ahead and choose the largest angle here. that's a little misleading. It's misleading because you're just looking for the biggest one, right? It could be 103. All it has to do is be bigger than the next biggest. Well, they didn't put them in order this time, but you're just picking the largest of them. There's no numbers in that problem. There's no way that I could just numerically say 103 degrees is going to give you the greatest. You're just picking the largest of the ones given. Okay. The figure below shows the length of side DC equal to 120 units and the length of side DB equal to 160 units. What is the length of segment AC? Okay. Well, basically the easiest way I can explain this is if I connect, you have to be a little careful when you draw things that aren't on the figure, but if I connect this, if I connect D to A, I get a trapezoid. And these marks tell me that it's an isosceles trapezoid. Basically, if I were to extend these down somewhere here, I would get an isosceles triangle at some point. So what's going to happen is if these two are equal, then DB is going to equal AC, and AC is going to equal 160 units. Now, I'll take a minute here and say why we can do that. Well, it is an isosceles trapezoid, but it also, we have congruent triangles here. Triangle congruency is a big part of geometry. I'm not gonna go ahead and that's another lesson altogether. But basically, I have this angle equal to that angle. I have these sides equal, and I have this side equal to itself. Right? CB is equal to CB. This is not a complete proof by any means. Angle DCB is equal to angle ABC, and it's given that DC is equal to AB. So from that, it's called congruent parts. Corresponding parts of congruent triangles are congruent. CPCTC. So DB is going to be equal to AC. You might be able to look at that figure and guess that. Also, if these angles are the largest, then these sides are going to be the largest, so we're not going to get the side of the triangle larger than 160, so that kind of eliminates these two. But basically, corresponding parts, congruent triangles are congruent. Okay, I'm going to go ahead and end part 2 here, and the next time we'll start with number 12. As always, thank you for watching. Please ask any comments and questions you might have. Thanks again.